Today, we're doing multiplying and dividing into scientific notation. Just like multiplying and dividing of decimals is easier than adding and subtracting. Adding and subtracting takes a lot longer than multiplying and dividing with variables as well. This is no exception to that. Multiplying and dividing is a lot more straightforward. You can get it done quicker. So, multiplying numbers in scientific notation. The reason why it's easier is because the exponents, they can be different, unlike adding and subtracting where we had to first change the exponents to being the same thing. That's a review from yesterday. Exponents may be different. You're going to multiply the factors together and then add the exponents, and that's following the exponential law of multiplication. The exponential law of multiplication. That's the one where you add the exponents together.
How do you spell coefficients?
C-O-E-F-F-I-E-N.
I-E-N what?
I-E-C. I need to write it.
I don't think that's right.
If that's not what I meant to say.
I spelled it right.
Another word for a coefficient, Stephen, I looked into it more since I couldn't give you a good enough definition of coefficient as it applies to this. It's just the constant. Constant. Okay, the constant. What stays constant in this one? N is always going to be N. M is going to be M. It's just a constant. M, yep. Until Aiden?
Okay. This is a very important question, but it's not math related, so I'll ask you another day.
Thank you. Appreciate you recognizing that. Make sure you get the general formula on that. General formula. How I Met Your Mother references.
Why would we watch that? Because I'm watching Chuck.
Formula. We have N and M, where N and M are numbers. N times 10 to the x multiplied by M times 10 to the y is equal to NM times 10 to the x plus y. In the formulas that we had yesterday, we had it be 10 to the x, or 10 to the power of x, because they had to be the same thing. This one we do not. Does anybody not have that yet? Yes.
I feel like division is hardest just because it includes dividing.
That's an interesting way of putting it.
Because dividing is the hardest thing to do. Multiplying is pretty easy.
Example 1. Here's what we're given. We have 3.42 times 10 to the 5th, multiplied by 4.67 times 10 to the 9th. First, what we're doing is we're going to take out the decimals, take out the constants, and multiply those together like we normally would. And just as a reminder, you ignore the decimals, then put as many decimals that were in the original for multiplication. The next part we would do is we would add the exponents. And 5 plus 9 is 14. And that will give us 15.97 multiplied by 10 to the 14th, times 10 to the 14th. But that is not proper scientific notation. Proper scientific notation is where x is greater than or equal to 1 but it is less than 10. Yes?
So in scientific notation, will there always be 10 as the base?
Yes, always base 10. Great question. Yes, scientific notation will always have base of 10. That's a great question.
Why is that?
That's just because we do a base 10 counting system in science.
Yes.
It's not like a baker's dozen where it's a base 12 or a base 13.
Baker's dozen is 15. Also, I
Okay.
got some of like.
So if you got 3 baker's dozen, it's 36.
Really eat.
Bert.
Can you use variables inside of
Yeah, technically, yes.
but we're not going to be using them?
Not in the immediate future. Example 2. We have 2.93 to the 10 times 10 to the power of negative 2 times 8.3 times 10 to the power of negative 5. Now don't confuse this with switching the numerator and denominator like we did last test. Okay? Don't worry about that right now because we are just needing to get it in scientific notation. We're not putting anything in the denominator or switching it from different spots. Yes? Oh. Well, no, the 10 to the negative 5, if you recall. Oops. Did I restart the recording? Okay. Because you know that. Don't confuse that with us moving things in the denominator. Yes.
On the last one, do you round that number?
Oops. On the last one, push pause on your copying.
I can't do that.
The last one,
Like the number would have to be multiplied because I got 15.971.
yeah, I think we're going to go to just 3 decimal places. I think we're going to go. Yeah, we'll go to 3 decimal places.
But that's only 2.
I like this a lot better.
Oh, the final answer. Got it.
This one goes to 4, so I guess just for time reasons when they made this. Yes. $4.67. Yes. Yes. Yes, sir. How do you get the multiplication out of the top?
How do you get that?
It's not. There's a symbol. There's a symbol for it in Microsoft. He was just talking about the multiplication symbol that's right here. Because clearly it's not anything else that's typically in a different font. Bert. Because in scientific notation, that's where it is an X, and make sure it's a capital X. Because the algebraic X, as you know, kind of has a tail on it. Okay? And it's italicized, if you will. And the major X is, since it's scientific, in science they use it like that. Okay? Yes? Yes. Okay. So multiplying decimals first. Second, we add the exponents. Negative 2 plus negative 5 is negative 7. The answer is 24.319 times 10 to the 7th, but we need to make sure we have it in scientific notation. So we need to bring the decimal to the left, which means that is going to get lighter. Remember, decimal to the left. The exponent gets lifted. So it lifts from negative 7 up to negative 6. Yes, sir?
Because you moved it by 4.
Yes, because it was here. Let's make this royal blue.
Place, that means that it dropped. Because it goes to the left and it drops and goes to the right and it
No. Goes to the right, it reduces. The decimal goes to the left, it gets lifted, as in goes up.
So if it goes to the right, then it'd be like negative 8.
Yes.
Yeah.
Okay. I don't think you said it the first time the way you meant to.
He usually doesn't do that.
Now dividing numbers, on the other hand.
It's a lot harder than multiplying.
Yeah. That star thing looks like another just multiplication. It's just smaller. Did you copy all that down, Artie?
I'm working on it.
Thank you. Dividing numbers in scientific notation. The exponents still are able to be different. So it's different than addition and subtraction where they have to be the same. Then we have divide the decimal numbers, subtract the exponents, and it looks like that. General formula is n times 10 to the x over m times 10 to the y is equal to n over m multiplied by 10 times x times 10 to the x minus y. Yes, sir?
What does it mean by general formula?
General formula is he was a commander in the army between the years of the general formula is no matter what numbers you're using, you can input them into that. That formula is going to be for anything. You're going to have two numbers, and you're going to have two exponents.
Wait, can you use this with three numbers?
We're not going to.
Then you can't.
You would just have to use order of operations, and it would turn into that. For example, so I'm going to rewrite that general formula since you were interested in knowing how that goes. So here's, using the general formula, I'm going to evaluate or substitute in what we have. So 8 is our n. Do you agree? Do you see how 8 is the n? So I'm going to make this an 8. And I'm going to make this a 2. My x is -3. My y is -2. 8 divided by 2 is? 4. Times, then this down here comes to be -1, and I have -3 minus -2, which is 1. It's already in scientific notation because I have a single digit, and then decimals after that. And the decimals after that would just be 0.0000, not needed.
So that
Yes,
would be the
yes, sir.
But in this example, 8 and 2 would be like 8.9756 possibly.
I couldn't hear you because of the distracting knocking.
So this given example, 8 and 2 can be like 8.97214, and that's still be your decimal number, and then you divide that by 2. I am so lost. Yes. Can I go up and show you?
We'll get through this and we'll see if that question's still there after we do our example from the homework. All right, here's another division sample. Okay. Another division example. We are going to insert that into the formula to rewrite it the way that it was in the formula. So it looks like that. Just as a reminder, you want to move your decimals away. The denominator shouldn't have any decimals in it. 123, that's going to be twice. 46. I just did that backwards. Three.
That's not how you pronounce it.
0.99. Bring that down because it doesn't go into 99, but it'll go in. How many of these more I have on that? Ooh. $605. I'll try 5. Darn, 4. 4. So I got 123 times 4. That'll be 8. 8 goes in a bigger number, so that would round to 81. Yep. Oh, we rounded there? How'd they have 8? 805. Got it. 805. So 2.805. 2 minus negative 7. We got the 7 already. And they rounded to just 2 decimal places. 2 decimal places for the final answer. You know, yeah, yes. When dividing scientific notation, only go to 2 decimal places so this doesn't take you 2 hours tonight.
What about multiplying?
Multiplying, that one tells you how many decimal places are in it. Round to 2 decimal places for your responses. 2.81. Because we rounded 2.805 to 2 decimal places. Yes, Phoebe?
For multiplication, how many do you want to start with?
It already tells you how many it is. Yeah. Because if you have 2 decimal places multiplied by 2 decimal places, your answer is going to have 4.
Will any decimal places go over 6?
I think there were, but yeah, I think there were. All right, so as far as practice quiz questions go, because after we're going to have a, excuse me, a quiz coming up in, I think, 3 days. But these are the sort of things that you would want to know and remember from the last 3 days' lessons. Okay? So are you hearing me, or are you just waiting to ask your question?
We want to know how to answer these.
Exactly. Because this covers what we did on these 2 here were Friday. These 2 here. These 2 here were today. This one here was exponential law from 2 weeks ago.
Is that our homework?
No. So you can just write those down. Write those down as possible questions. I'm going to give you guys your homework so we can get started on it, and we can do an example. Yes.
I think I know why I do all this stuff. No, it's my dad's fault. Why?
No.
I've heard him make a song in his head and just tap it on the steering wheel of the car. Like at least once.
What
Did you write all that stuff down? Stop talking. Everyone, stop talking. I want you to write those 3 things down, or those 5 questions down. I see a lot of you ripping your notes pages out of a 3-ring binder and stuff like that. That's a really good way to lose it. It's a really easy way to lose your stuff. What's that? No, those are questions that you could be asked. You have to know those to be able to do these right. I'm not worried about your pen right now. Yes? Yeah. So just as a reminder, we're not working these out. We're just writing those down as possible ways that things could be asked. I don't think you're going to borrow it, probably use it. Okay. We're going to do actually number 5 on there. We're going to do number 5 on there. Let's see if I can get this to work. All right. See how close that was? I was trying to line that up. That's a 3. So with exponential laws, you remember that you need to bring this 4 into everything inside. This is number 5 that was on what we just wrote down. You know, I have to check with Mr. Holland on something before I sign that to you. Okay? No. I need to ask Mr. Holland about a couple things.